everybody. So, as I said, my name is Millan. I'm working here in Workday for 1 year and a half. So, essentially here, the main purpose of this meeting, at least the main purpose of this talk, is introduce a little bit about another features that we can do with Node.js, because Spirit was asking before how many of you play with Node.js in your companies or something like that. Now my question is, how many of you that you do that use it as a UI server? And the other one, how do you use Node.js? Nice answer. No answer about that. Essentially, Node.js, the conception of Node.js is creation of endpoint, RESTful services, and UI servers. So there are plenty of applications like Happy, Express. Even you can create your own one to have a point to touch the backend, that is a REST endpoint, and serve the static files. The idea is that Node.js can do a little bit more. Actually, can do a lot of things more. So one of the things that we have daily news and all those things is big data. So big data is on all the places. So anyway, so oops. So well, that's my contact. If you want to reach me or something, feel free. And actually, I would be really happy to answer everything that you want to ask me after the meeting. So feel free. So essentially, the thing that we are going to talk here is about something that at least how many of you knows Hadoop, or are you using Hadoop here? One. Another big data infrastructure like Spark, or two. Nice. Cassandra. One. That's good. Two. Perfect. So the idea is those are frameworks or architecture or applications that we are going to use to handle big amount of data. So by default, they provide capabilities, utilities, or even access to handle that massive amount of information and provide some analytics that we can use to do whatever we want with that analytics. So the idea is Node.js, Hadoop, or Cassandra, or MongoDB, or whatever, they are friends. They don't need to be enemies. Actually, Java is good to handle Hadoop, but as well, Node.js can do things with Hadoop. So, if we go to Wikipedia with, essentially this is the definition that we have there, is big data is massive amount of data, so we need to take care about how can we handle that information, essentially. So, let's do a kind of simulation of numbers about something that we used to use every single day. So if we think about our mobile phone by default, well, not by default, we have a capability if we are using Android, that this is to share our locations to find my mobile whatever point. So essentially the thing that we are doing is send to the Google servers a chunk of elements that could be like this one. It's not that one, but it's more or less similar. So it's almost 140 bytes. So if we do more numbers, I mean, because that is a small case, but if we think bigger, so if we consider that we are going to do 12 requests, one every 5 minutes, we are going to have this amount of data. If we consider that we are going to have 24 hours, so by 24 times. And the lovely CEO of Google said that there are 1 billion of active Android users, so let's do more numbers. So let's assume that the 50% of the people is going to disable that because they don't want to know essentially the life, they don't want to share the life with Google that they have, or even they don't want to share the position. Actually, it's totally normal, don't share the position. But anyway, this is this amount of data. If we do that, in total, we will have about 280 teras, 300 teras per day. So, and the good thing is that they are going to play with that data. So, in some way, they need to provide that information and even provide to the final user the final location, the point that we are in the map, the route that we were following. If we, for example, are using the Google Fit or whatever, that this is following all the tracks that we are doing and telling you if you were running, walking, or even cycling or whatever. So that information needs to be stored. So if we think in Microsoft technologies, okay, let's consider how can we do that with MySQL or Microsoft SQL or even Oracle SQL. It's quite difficult, and actually because so many times we are going to have unstructured data, so that's perfect for MongoDB or Cassandra, even because that's based on JSON objects and files, so SQL is not going to be able to play with that. So, but there are other alternatives. Actually, the main alternative that we are going to use it is Hadoop, Cassandra, MongoDB, even Couch. I put there MongoDB, but how many of you works with MongoDB? Sorry. So let's play with Cassandra. So Cassandra, well, essentially how the big data works. Essentially, we need to think that divide and conquer is the main thing that we will have over there. We are going to split the data in different clusters, different nodes, not Node.js, different nodes, that we are going to share the information. So we are going to have a slave cloud, and we are going to have a master, or a bunch of masters that are going to synchronize those slaves. This is more or less architecture that we will have in Cassandra. Actually, this is essentially the first thing that you can find when you put Cassandra and images in Google, so this is the main one that you will have over there. This is, again, showing Hadoop. So Hadoop is essentially the same thing. It's one master, slaves, and we need to share the information with those components, and we are going to have like workers. I mean, we are going to have a small worker, and we will provide information to the main node that is going to extract the analysis that we will do, or whatever. I mean, that's up to us. So, what if we think that we can do that with Node.js? It is possible, actually. So, the idea is Node.js is quite good because if we think in the footprint that we are going to leave in the memory with Node.js, it's quite reduced. It's small, it's really small actually. We don't have anything in memory when we are loading Node.js. And the other thing is the BH engine that is using Node.js is quite good when we are going to compile the JIT. So we have a good alternative. I'm not telling you that this is the best alternative. And actually, the purpose of this meeting is not create expert using that because it's impossible. The idea is to show a different way to use Node.js using big data. So, all those, apart from the main reasons that I was telling before, Node.js have plenty of good modules in the NPM repository that are able to handle and extract the data and create some kind of analysis of that data and provide, in the end of the day, information that we are going to need. So that is quite powerful. Actually, I will tell you a couple of utilities that are quite good to use. So by default, Node.js for free comes with one cluster capability. So if we have one laptop, and we have an i5, i7 processor, no matter, we are going to have different logical processors there. So Node.js by default is able to create an instance for those processors and work in parallel. So this is a cluster capability that Node.js provides. And that's for free. You don't need to do anything else. Well, you need to obviously write that, but it's coming. It's in the API that Node.js provides. So it's quite good. As well, you know, single thread non-logging capabilities and all those things that the guys of the Holding, that this is the company that created Node.js, said. By default, now JavaScript is providing, plain JavaScript, not TypeScript or something like that. Plain JavaScript is providing nice capabilities to create maps and produce off arrays. So it's not the best one, but it's an alternative. So we can use it. Of course, I don't want to put that line, but I need to put, yeah, fits perfectly with MongoDB. Sorry. So, apart from that, in the NPM repository, we will find a couple of interfaces that are quite good. So, utilities that we can use daily if we want to consume Hadoop services or Cassandra services or whatever are there. I mean, there are in the NPM repository you can find something like web HDFS, data stacks, and this is the connection with Cassandra, MongoDB, Redis, if you want to provide NoSQL database to use like a cache or something, Node.js, well, communication with the Amazon Web Services as well. So we have plenty of things to play with in the NPM. Apart from that, once we have the information stored and we can access to that information, we can process that information. So we have utilities like underscore, SQL, that this is quite good because we have an in-memory array and we can play with that in-memory array like a SQL database if you feel comfortable with the SQL language. So it's quite good. Diagnose, the scale engine, and actually I'm going to do a big mention about that later. Not EXX. So we have a lot of things to play with. So essentially those things are connectors, manipulation of that data. So let's continue. So actually the main thing that I would like to talk in this one is about, and actually this is a good point that to talk, is about one application that I discovered a couple of weeks ago. It's called Scale. Scale is a framework that is for free. Actually, they have a GitHub repository. You can visit that website. So they are doing something quite cool. They are creating a bunch of clusters. It's the same thing that I was exposing previously. They are creating a bunch of clusters, and they have a master. And the thing is that they are going to do parallel processing in each cluster that they have over there. So what is that? That is a Spark, but in Node.js. Obviously, that project is extremely young. The performance is not going to be the same that we have in Spark. But this is the beginning of something really big. So my suggestion is if you have time, keep an eye on that project because it's amazing. And actually, if you want to collaborate in that one, it's really good. I recommend a lot that one. So let's have a small demonstration. So any question before to go to demonstrations? Go ahead.
What in terms of HDFS clusters, let's say having a Spark layer over it, normally I suppose the convention prefers functional languages like Scala with a higher level of abstraction and the functional capabilities of Python in order to get the dynamics of a cluster right.
Yeah.
What would Node.js as a language outside of the front end when you're interfacing with web front end interfaces, what would Node have if you start going back into the cluster? What's the benefit over Scala?
Yeah. Let me, first of all, Node.js is not a language. Node.js is a framework. So I don't know if you're aware about Scala.js. Scala.js is write Scala and transpile to JavaScript.
That's Python guy.
So anyways, so the idea is, first of all, by definition, JavaScript, if we think only JavaScript by definition, JavaScript is not essentially an object-oriented language, and it's not a functional language like could be Scala. But if you go forward with, for example, the implementation of ES6, that this is the latest version of, well, not the latest, more or less the latest version of the JavaScript language, it's quite functional, and actually it's quite similar to the things that you will have in Scala. Obviously, Scala contains a lot of capabilities like immutable variables and all those things that are quite handy to play with those elements that you have over there. So that's the point. You can transpile those elements that you have immutable in Scala using closures in JavaScript. It's not the best approach, but it's a good approach.
But don't you have things like chaining in Scala or in JavaScript that would be an issue on clusters if you're writing code for it?
Well, it depends. It depends. Actually, this is something that the library, for example, let's talk about HDFS. HDFS is essentially a file that we're going to put in one repository, and that's it. So the idea is you will have there the files stored, so you will connect only with one master in that file repository. The thing is, how do you access to that one? By default, Hadoop is going to provide an API, so I don't need to take care about too much about if I'm going to, what kind of language I can use, and actually, you can access it directly with a REST endpoint, and actually it's a REST code. Yes.
Right, but there's an awful lot of people would be using, accessing HDFS in layers above it. For instance, Spark is a common one.
Okay.
Flink is another one as well.
Yeah, of course.
So I suppose my question is that, like, for the implementation, Scala is very common, and also Python is as well, because folks like to not veer too far off the beaten track because of the quality of the evolution of these type of platform layers. In your opinion, is there room for Node to maybe improve upon what's already there? Or?
To be honest, it's really early to discuss about this. I mean, maybe in the future, yes. But for example, in my work, my daily work, we use obviously Spark. Obviously, by default, Spark is coming with the Spark shell, that this is Scala. I mean, you access to the Spark context using Scala. You can use as well Python, but by default, it's thinking in Scala. Well, they say that maybe you can use Java, but I prefer don't say that because it's quite ugly to write.
Python's close cousin anyway, so.
Okay. No, so for that reason, it's an early stage to say, yes, it's amazing, you can use it, but we can build something. I mean, maybe in 1 year, 2 years, we could have something more decent than we have so far.
Greenfield site to be filled then.
Yeah.
Got it.
Thank you. Any more questions? Perfect. So let me use it. Okay. So first of all, the first thing that I would like to show you is how the Cassandra. Oops. So, how the Cassandra driver works. So essentially, I'm going to have here in my local host a Cassandra. So it's going to be only one instance. So it's more or less like a MongoDB or SQL database, the thing that I'm going to have it here. But essentially, it's only an approach. I don't care too much if that is going to be a cluster or not, because in the end of the day, that's going to be irrelevant for the point of view of this presentation. So the idea is, and actually, if you look at this code, this is JavaScript, and it's like functional or something, because if you look at this, you have the functional inside the other function, like Scala, so it's quite similar. So the thing is, for free, we have in the npm repository one driver called Cassandra driver, so we can download. I have my Cassandra there up and running. So it's extremely easy to execute whatever in Cassandra. So the only thing here that I'm going to do is I'm going to connect to my Cassandra server in the host here. For example, if we have a cluster of Cassandra, the only thing that I need to do is add the other IPs or host names that are using as well the same implementation of Cassandra. So I can connect. I'm going to close the connection. That is quite easy. So even the driver provides the capability to write something quite similar to SQL. So here I'm going to create a key space. This is like a database in SQL or whatever. And I'm going to, well, inside that I can create tables or whatever. I'm going to remove that key space. And actually, let me to do that demonstration. First of all, let's comment that line. So if I execute it, let's do this one. Let's kill the client. Client shit down. Okay. So if I execute that Cassandra test, so we have the output, and now I'm pretty sure that I need to refresh that one. Okay. So now if I expand, I'm not sure if you can see that. If I expand the case spaces, now we are going to have the examples. You can see there, example key. So zero effort. I wrote the creation of that key space in SQL, and it was only one line. So now I'm going to remove it. So let me do this. See. There you go. So now if I run that again, so if I refresh, bye-bye. So it's easy, extremely easy to play with Cassandra and Node.js. So we can write our own application, and the data source is going to be Cassandra. If we know SQL, we are going to be able to play with big data and Node.js. Even we can put an express layer in the top of that implementation and serve that data. That's up to you. Or even you can create a microservice with Doc or whatever, play with that implementation. So this is Cassandra. Any questions? Nice.
Problems with scalability?
There are problems, but that is again something that, for example, the touch point that you're going to have in Cassandra is always the same touch point. It's going to be the master, the Cassandra master, and you will connect with that master. So, scalability in terms of what? Cassandra or Node.js?
So what I'm thinking here is failovers is the first thought. How it handles failovers, create fault tolerance levels, and also in terms of data replication. Does it go to 5?
Yeah, well, think about that. Again, Cassandra is essentially the data source. The thing that we are doing here is getting that data source. We are not manipulating that data. So if we have, for example, if one node of Cassandra is down, it's the proper implementation of Cassandra, the thing that needs to handle that. In terms of Node.js, if we...
Are you thinking distributed or non-distributed here?
Distributed, always.
What's the value?
Sorry?
What's the value?
The value of this one?
Yeah.
Essentially, you don't need to have a Java or something like that to consume those Cassandra services, Cassandra database.
For Java or JavaScript?
Java. Yeah, but this is, I mean, if you are a Java developer, that's okay for you. But if you are a Node.js developer and you want to implement your own Cassandra because all your full stack is Node.js, how do you do that? This one.
Because Node is easier to use than Java, right?
Exactly. Exactly. So the thing is, don't think that what is the value or Java can do the same. Of course, Java can do everything. The idea is that Node.js can do more or less the same. And now with the new technologies that the guys are implementing in a lot of repositories or something, if you are a full stack developer in Node.js, for example, the guys in nearForm, or even people in Red Hat, in Waterford are doing everything in Node.js. They have 0 Java, 0 C++, 0 whatever. Everything JavaScript in Node.js. So, if that answer what's the value, for those guys, they are making a lot of money with that one. Eh? A lot of people, actually. So anyway, if you want to discuss about the scalability of that one, let's discuss after the meeting and all those things, because it's quite interesting your point of view about distribution and all those things in Cassandra. So
yeah, it goes crazy. I had a Spark SQL script today,
okay.
and the senior guy couldn't figure out why it kept on maxing out the core. So I went and blew up with like 2 clusters already. So I'm going for a hat trick now tomorrow. So.
Okay. Perfect.
Scalability is a real issue.
This always is the issue. Anyways, but anyway, if you want to talk after the meeting about that, or even you have my email or whatever, we can have a discussion and even share ideas, because it's a real problem.
Yeah.
To be honest, it's a real problem. Not only in Node.js, it's in Java, Scala, C++, C# or whatever. It's always the same problem.
Scala addresses a lot of scalability issues, but a lot of it is customized add-ons depending on the stack, configuration of the stack. But Flink is a new publication or a new version which promises to solve some of the
Nice. Good.
2 in 1.
Any other question? Perfect. So, so this is something that we can do. This is the value of Cassandra here. So let's jump to another implementation that is quite, I create a demonstration to show how can we access to one HDFS implementation. So essentially here, I am going to use the web HDFS. So the thing that we are going to do here, I have my Hadoop HDFS here up and running. So if I would show you, yeah. So this is my directory of Hadoop. So it's empty. So the idea that I want to do is, I want to show is, I'm going to have a small one, relatively small file. It's going to be a book, and I'm going to upload that book here. Actually, it's quite a straightforward example. So I'm going to upload the book into web HDFS, and actually I'm going to read that. So I'm going to do a streaming to Node.js. So value of that one, again, same. I don't need to have a Java implementation in the top of that web HDFS or even Scala applications or something like that. You can write that directly in Node.js without any kind of effort. So the guys here, I wrote this class here separately. So to connect to Hadoop, well, HDFS is as easier as create this client. So the only thing that I need to specify is that I'm going to use, I'm going to use the module web HDFS, and I'm going to create a client with one user in my local host, in the port that traditionally when we install Hadoop we will have. So that is the, and I'm going to return that module. So here, sorry. So here the thing that we will have is, well, I'm going to put the time, I'm going to the seconds that we will have over here. So I'm going to extract the time that I'm going to start the execution. I'm going to create, the cluster is not necessary, but I put that one as an example because we can separate in my cluster, Node.js cluster, the same to process the file and all those things, if the file is extremely big. But in that scenario, the file is not big, so that line is not useful so far. So I'm going to read the file, I'm going to load the module to read the files, I'm going to load my module to create my Hadoop. I'm going to create a string, an in-memory string of this file. That's going to be historical tour. So this is book. Actually, it's for free. Let me move this one. Sorry. It's for free. So it's that book. So the thing that I'm going to do is I'm going to save that file into my Hadoop instance. That's going to be really, really easy. The only thing that I'm going to do is open my client and write everything in that location. So once I have it, I'm going to pipe the content of that one, and I will have, again, I will be able to read the content of that Hadoop file, file that I'm storing in Hadoop in my Node.js instance. Apart from that, one of the other things, so with that one I'm going to show how can we write using the web HDFS, the API that is coming with Hadoop. Apart from that, Hadoop offers another thing that is called Hadoop streaming, or something, I don't remember exactly, it's streaming, yeah. So this one is when you pass one stream to Hadoop, they can create, well, by default you can do some operations of map and reduce or something. So the idea is we don't have a driver in Node.js, but Node.js is quite handy to, it's quite easy to execute commands using child process. So the idea is that I'm going to create a child process and I'm going to execute that command line. So here it is the command line to execute that implementation. So the thing is, my function to create the mapping is going to be a JavaScript method. So here, that is going to process the content of that file. It's going to map the content of that file. And actually, the thing that that function is going to do is split the content of the file in words, and I'm going to put all the words with one value, 1. So I will have a bunch, well, all the words of the file with value number 1. So I have my map operation, and I'm going to do the reduce operation. The reduce operation is going to be this one. I'm going to add the numbers that we have, because always is 1, we are going to add those numbers, and we are going to do a final count of repeated words that we will have in that book. It's quite easy. So the thing is, we are going to read a string, and we are going to return another string. Nothing else. So when I execute that one, so, yeah. Let me do that. Now let's start. So when I execute that one, if everything is working properly, finger crossed, that is going to write in the Hadoop. It's going to read the content of the Hadoop, and it's going to string the result to the operation of map reduce into Hadoop. So let's see. It's taking a while. So meanwhile, if we go to the Hadoop here, if we refresh, oops. And we put here some variables. I promise that was working. Save here. Okay. Oops. Well, I have a problem with the communication with the Hadoop, sorry. But anyway, I can pass you the source code of that one because it's quite cool. Actually, it's a pity that now it's not working. Please, let me check it out last time. Yeah, no, I don't. I need to figure out what's the issue. Because it's in the read, and it's what we are trying to write in the Hadoop database, or something. Maybe it's because it's not started properly, the Hadoop implementation. Anyway, I can provide you the source code and play with that. The only thing that you need to do is provide in the code that you will have in the client, you can provide the URL, and that's it. It's not very, very difficult. So, more or less, questions about this implementation of Hadoop? Exactly. Hadoop is down. Okay. So.
Just a comment, it looks like, I love the Python implementation. It looks really clean. It looks really nice.
Thank you.
Just a shame it's not working. It looks like a great approach, right?
Thank you. Well, it's quite easy. I mean, it's nothing special. It's quite straightforward. The only thing is, obviously, it's not Scala. And actually, I prefer to write that in Scala with a proper implementation of Scala. But with Scala.js, you could have a real approach of the implementation of that one. If you want to use Node.js, again, if you want to add the value there. So,
well, but the use of pipes, right?
Yeah.
The streams in Node, right?
Exactly.
Is exactly the way that.
Exactly. It's exactly the same way. Yeah. So, any questions on that one? Any more questions? Perfect. So, and now, let's talk about the last project that I was discussing over there. Actually, it's going to be really fast because it's late. So, the thing is, there is the community of, there is a small community, one project called Scale is quite good. They are doing a really, really nice job. Again, please review it if you have time, and if you love Node.js, review it because it's quite good and it's quite powerful. And actually, I have the pleasure to write something over there. So the guys there, the thing that they are doing is creating something that is like a Spark implementation. Obviously, you know, Spark, essentially the thing that it's doing is create something like an in-memory. And actually, sorry, the thing that I'm going to tell, but because it's not true, but it's an approach. The thing that this Spark is like a bunch of clusters that are going to share the same memory. So every time that I'm going to access, no matter what cluster, I'm going to have access to whatever point of the memory that I have in my cluster. More or less. Is it or not?
Which is this one?
A Spark.
Spark, it operates in micro batches, but it pulls from disk.
Yeah.
It processes in memory.
Exactly. Everything is
micro batches.
Exactly. So the thing is, all the processes that you will have over there will be running in memory. So one of the things that a lot of companies are doing is essentially loading the content of Hadoop files into Spark. Essentially because they are going to provide the same map and reduce operation, but because you will have in memory, in Spark, the Hadoop file, once you read that, you will have a really fast access to whatever point of that one. The map and reduce is going to be really fast. So if you keep an eye on that one, it's quite powerful. So the idea is create something similar to in Node.js.
But what do you mean by shared memory?
Between different classes.
In Spark?
Yeah. It's like a cloud. Actually, it's the definition of the cloud. So,
I think I get Sultan's point there. The Spark normally runs as a layer on top of, let's say, HDFS.
exactly.
So I suppose the question, is this your question, is what does this project do that's different to Spark in terms of its relationship, let's say, with HDFS? Is it?
No, I mean, how do we consider like it's a pool of memory? Like
Exactly.
Each Spark node.
Well, there's a few things going on. Let's say if you have, let's say, Kafka running Kafka and Hadoop clusters, they're not the same. You have to have two instances running. So let's say there's a new thing out by Apache Myriad that will run a schedule that will sync and it will cooperate between the two. So you can run single schedules using Myriad. But in terms of sharing the same memory, having one cluster for everything, that would be quite revolutionary. The nearest I've heard so far has been Apache Myriad. And that's really just looking at data center operations. That's very, very large organizations in terms of that.
Yeah. And actually, this is the main point of the cloud computing in a lot of companies, actually. I will tell you.
Yeah, but between clusters there is a separation.
Yeah, that's it.
You don't have one memory rotation between the different clusters.
Exactly, but you have an easy access to each point of the shared memory that you have over there. Actually, if you want to, I can provide you a lot of documentation about that.
Yeah, maybe we discuss it.
Sure, because it's quite powerful. And actually, Spark is an open source project, so you can review the Git repository of that one.
No, I'm working with Spark, but like we don't have shared memory between different clusters.
You do have, actually. Actually, not, I can tell you that one company that I know won't work. Yes, you do.
What do you mean by Hadoop nodes talk to each other all the time, so they are sharing information.
Exactly.
Sharing information, not sharing.
Yeah.
No, of course. I mean, they're sharing information, but using the single, well, if you have more nodes, if you have more cluster of Spark, you will have more powerful of computing, and this is because you have more memory to put in play.
Within one cluster. Anyway, we discussed
Yeah,
it.
perfect. So the thing that we have over there is the guys of the scale. The thing that they are doing is exactly a copy of Spark in Node.js. So the idea is, the thing is, you will have exactly the same thing that you have in Spark context. So you are going to have a text file. So you will do the operation to do the flat map. So this is a map operation. So the thing that we are going to do is separate in words, so that we will have words. And actually we are going to do a count of words, so that's very easy. So after that we reduce and we will provide a value of each word that we will have over there. So we are going to do the same count, but in those line of codes. So sure.
Sorry, I know it's late. Are you, in terms of follow on from that piece of code there, that's quite impacting on any job that's happening there. Is it all JavaScript libraries that you'll be relying on?
Yeah.
So you're purely 100% JavaScript from there on in?
That is totally JavaScript.
Okay. So you in terms of like code like that, I would have seen and written and followed on then with the follow on the platform to, I would feed a Spark data frame, let's say. I would feed it across to pandas because functionality in pandas, this is all Python of course, functionality in pandas will be a little bit different from what I wanted.
Exactly, but this is because they are different languages. I mean,
well, yeah, no, it's the same language in that example. So I've ran the initial job in Python.
Mm-hmm.
So what you have there, I would have done in Python. And then I would have fed that into, I would have created data frames downstream and fed in from that particular piece of code, the Python version, into, I would have Spark data frames returned within the SQL context. And then I would feed that then into pandas because I wanted to do something else with that downstream, so to speak. It's the same kind of thing, the same deal is here except for Java?
Exactly.
Okay, all right. I just
Exactly.
want to make sure it's the same.
Yeah.
Train thoughts, right? Okay.
Yes.
Thank you.
Yeah. So this is the code that we are going to execute in JavaScript. So the only thing that I need to do is go to that directory that is here. And now I install Scale. This is the framework that we're going to execute again. Is you can install using npm-g install Scale, so it's quite handy. So if I do that, I finish the job in less than half second. And this job, the output, is going to create a file over there with all the kind of elements that we have in that book that I have over there. So if you go here, this is the output. It did the operation with 0 effort. Well, not almost 0 effort. Again, everything in JavaScript and Node.js. Nothing with Spark, Hadoop, or whatever. So again, that project is quite good, quite interesting. My suggestion is please keep an eye. This is amazing. You can collaborate. I think that I can see a lot of future in that. That's up to you. So, any other questions? Okay, thank you.